is reasoning and conjecture. We have 3 vocabulary words for today. Okay? Our first vocabulary word is that word conjecture. It's a super fancy academic word. Conjecture. And conjecture means a conclusion, or it might mean a rule. Okay. I don't know why we can't just use the word conclusion in math, but we have to use this word conjecture. Because we're just fancy dancy. All right, the next word is inductive reasoning. We're going to learn about 2 types of reasoning in this chapter. One is going to be inductive. We're talking about inductive today because this is the type that you do all the time. All day long you do some inductive reasoning. The rest of this chapter is really going to be about deductive reasoning. So if you want to highlight, I know, I couldn't remember why I had a highlighter. I had it over there and I was like, I don't remember why I used this. I don't need it.
So today we're talking about inductive reasoning. Tomorrow we'll be talking about deductive reasoning. So if you want to kind of separate those a little bit in your brain, you might want to highlight that in part, that inductive.
Okay, inductive reasoning is what we do all the time. So it's easy for us to start with this and talk about this reasoning. And then tomorrow we'll talk about the deductive, which is a little bit more mathy. Okay, so inductive reasoning means that we are using patterns to create rules.
And this is something that humans are just naturally wired to do. We look at patterns all around and we make some rules. For example, if it's cold the last 3 days, what are you going to guess day 4 will be? Cold.
What are you going to probably put on in the morning without even checking the weather? Oh, yeah. Okay. If you notice in Mr. Tyson's class that 3 people have their phones out and they're not getting in trouble for it, what can you probably assume? What? That they're well, what if they're not even being sneaky? What if you just see their phones out and Mr. Tyson doesn't say anything? Yeah, he's just allowing it. You can probably assume that. You might have to ask, do you allow phones? But most people probably assume it. Okay? All right. Counterexample. This is that one that we talked about. Counterexample is one word. It sounds like 2 words, but it's all one word.
So counter is like a prefix. In this case, it means like another or an opposite. It doesn't mean like your countertop in your kitchen. So that's why it's hooked together there with example. That's one word. It's a counterexample.
So counterexample, it's not like an opposite example, but it's showing us why we're wrong. So counter here means like if you're going to counter an offer, you might have heard that like in a movie or a show. Like if I get hired somewhere and they offer me $20 an hour, I might counter that and say I want $23 an hour. It's kind of like you're challenging it. Okay? So counterexample is an example to show a rule or a conclusion isn't always right. So that's what we were talking about earlier. Generally speaking, most period 5s, where are you? In math class. Can I say it as a rule, every period 5, it is a fact, you are here in math class? No. We might be outside. We might be meeting the media center or the resource center one day.
You might be the only one gone, but you're still gone, so it's a counterexample.
So that's proving that that rule doesn't work. Okay? So that's a counterexample. All right, we have 5 examples today. Our first set is going to say, write a conjecture. So what does conjecture mean? A conclusion, or we're going to write a rule and find the next thing. Depending on what it is, sometimes it's a term, sometimes it'll be the next whatever we're talking about. Oh. Alright, so for example 1, we're just going to have a list of numbers. 4, 10, 18, 28, 40.
All right, so we're looking for a pattern that we can see.
So we're going to use our inductive reasoning. We're going to look for patterns. And what rule do you see is happening in that pattern?
So from 4 to 10, 4 plus 6 is 10, 10 to 18, 4 plus 8 is 18, 18 plus 10 is 28. How about from 28 to 40? 12. So what's our rule? What are we doing? Adding 2.
If we were adding 2, we'd be like 4, 6, 8, 10, 12. We would have that list. What are we adding to? What part are we adding to? Because we're not adding it to these numbers. We're not doing 4 plus 2 or 10 plus 2. What part are we adding to the pattern? Or we're adding 2 on to what we add on.
Add 2 more each time or something like that. Okay, so that's our rule. If we're going to try to use our inductive reasoning and apply that rule, what would come next?
How would we find it? What would we do? We would take 40 and do what? Good. We would add 2 to 12. 12 plus 2 is 14. So we're going to add 14. Or we could even write it as 40 plus, we could do the 12, but then we need to add 2 more, plus 2. We could do it that way too and just keep adding 2's all over the place. Either way, what do we end up with as our answer? 54. Really, this is what we're doing. Look at me using my order of operations. First, we did 12 plus 2. And then we got 14. Fancy. All right, number 2.
This is what we're going to do for our examples. We're going to look at a pattern. We're going to make a rule, find the conjecture, and then we're going to try to name the next term.
All right. Khalid. Khalid's with an apostrophe S. Possessive. Doctor appointment. Doctor appointments. So we're going to talk about doctor appointments. Okay, and doctor appointments, we notice he has an appointment in December. His next appointment happens in May. He then has an appointment in October. And then he has an appointment in March. ... We need to come up with a conjecture. We need to come up with a conclusion about Khalid's doctor's appointments, other than he goes to the doctor quite often. Much more than I do. And that's okay. Maybe, no. Oh, probably about the same amount, actually. Don't you think? Mm-hmm. Maybe. I don't know.
I don't know.
I don't either. What do you notice? How are we going to know what's the next month? Like, what's the rule? Every 5 months. So December
to January, January to February, February to March, March to April, April to May. Is that 5 months? That's 5 months. So let's go May to October. May to June, June to July, July to August, August to September, September to 5 months.
When I do month math, I like to use, when possible, I like to use like the month number. So like May is 5, the 5th month. 5 plus 5 is 10, which is October. But then it gets goofy because you do 10 plus 5 and you're like 15. What month is 15? It doesn't make sense, but in my brain it does. I don't know. So conjecture, every 5 months, what happens? Yep, Khalid has a doctor appointment.
So then remember, the next part is for us to think about what that next term would be. So if his last appointment was in March, when's his next doctor's appointment?
So what's 5 months away from March? You guys are a lot better at month math than I am. It is not my expertise. Clock math, calendar math, struggle. All right, we have one more example. I'm going to go to the next page because I'm not going to have enough space. I only have about 3 spaces here. You're probably going to need probably the same amount of space you used for number 2. So if you don't have that amount of space, go to the next page probably. Maybe do an arrow. I like arrows. I always did them on my notes. Just in case I thought that was the end. Surprise, it's not. For you. All right. So number 3, we're doing the same thing. We're going to do a conjecture and a next term. Okay, this one is dots. You guys ready? We're going to have a dot. Then we're going to have a dot, dot, dot.
Leave a little space between those. Different.
Then we're going to do nope, ignore that. All right. What do you guys notice? What is happening? What's that pattern? It's increasing. Good. There's
Conjecture.
Yep, conjectures. That's that conclusion. It's our rule. So we're increasing. By how much? This one's by 2, then 3, and then 4. So there's kind of 2 ways that people are looking at this. There's one that's looking at the bottom row and they're imagining it's getting stacked up, right? They're adding a row to the bottom. The way I actually imagine this is that we're adding to the right. Like that this was this one, and then I added 2. Then I had those 2, and I added 3. So there's kind of 2 ways to think about it. Both are right. They're fine. Do you guys think about it as like you're stacking from the bottom up, or do you kind of add one column as you go? What? Much simpler, right? Yeah. So we're going to add a column.
Remember, column is just like a row, except a row is when you go across the page, a column is going up and down.
I did a quick example there for you if you need it. Add a column. But when we add a column to the side, what else do we do? So if I started with 1, now I have 1, what's my next column going to have? 2. Then this one goes 1, 2, 3, 1, 2, 3, 4. So what's happening as we add a column? Yep, we add one more point. So for our next figure or our next term, usually we use that word term if it's not something that we know the name of, or if it's numbers. So how many columns am I going to have this time? 5, and it's going to start with 1, 2, 3, 4, 5. So I'm going to do 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. All right. Number 4. Just kidding. Before we do number 4, we're going to write down our directions for the next couple. Next couple, let's find a counterexample. So remember, a counterexample is showing that we are not right, that rule doesn't always work. It might work sometimes, but not always.
And the thing about how we're using these conjectures and these rules in math is that if we can even think of one time, one way that it doesn't work, it's a counterexample. Okay? So all we need is one way to disprove it.
All right, so our first one is going to be after school. I ride the bus home. That might be true most of the time. Do you think anybody at school rides the bus every single day after school? Can you think of a year, if you rode the bus, can you think of a year where you literally rode the bus every single day after school? Perfect attendance? Your parents never picked you up? You never left early? You never went to a friend's house? You never went to swim practice? So we have to come up with a counterexample. We have to think of something. When might be a day that you wouldn't ride the bus after school? You're sick. If you're sick and it's a school day, at 3:15, do you still get on the bus? If you were at home? No. What's another counterexample? Doctor's appointment. Or if you leave early, right? How many of you have left school early with a parent? Or someone picked you up from school, right? Okay, if you leave early, you're probably not riding the bus. Or if you have a sport, if you join an activity, you probably don't ride the bus right after school. You might get a bus home still, but it's not right after school, right? All right, that one's more like real life when we talk about counterexamples. Okay, I like to use counterexamples with my family when I was growing up. They'd ground me for things. They'd say, well, you went out past your curfew, so now your curfew gets shortened by a half hour. And I'd say, yeah, but my brother came home 2 hours late the other night, and you didn't do anything with that. Right? Not fair. It's a counterexample. Right? All right, number 5. All supplementary angles are adjacent. All supplementary angles are adjacent. So for a counterexample, I'm going to write down what we're thinking here. We want supplementary angles and are not adjacent. So can you try and think of a picture or an image? If you're not sure what supplementary or adjacent mean, you might need to take out those cards. They were at the very last lesson we did. Can you think of an example where we have a supplementary angle? What does supplementary mean?
You have to look back and back.
Supplementary? No one knows what supplementary means? Oh, they add up to 180. Okay, so we need two angles that add up to 180, but not adjacent. What does adjacent mean? Next to each other. So can you think of two angles? Imagine a picture where you have two angles that add up to 180, but they are not next to each other. Can anyone think of an image of what that would look like? Oh, and you got one?
Get up and draw it if you want.
Are you brave enough to get up and draw it? No? That's okay. Anyone else feel brave enough to get up and try and draw one? All right. So if I have this angle here, that looks like this. I have K, P, T, and M. My favorite thing is making up points. And then over here, I have another angle that looks like this. Looks like this. And that's called L, J, A. And I know that this is 50 degrees. And this is 130 degrees. Are angles TPM and LJA, are those supplementary angles? Do the angle measures add up to 180? Are they adjacent to each other? Are they right next to each other like these ones? Nope. So that's a counterexample, because this person thinks all supplementary angles must be adjacent. And we just showed them, no, look, it doesn't work all the time. Here we have supplementary angles and they're not adjacent. This says 50. 50, 130. All right, last one. Number 6.
Number 6.
Last one. All right. If AB, segment AB, is congruent to segment BC, And then B is a midpoint. So if we have two segments that are congruent, and it's A, B, B, C. Can everyone kind of imagine like that line where you have A, B, C, and you have A, B, and B, C? Okay, in that general idea of how we've normally been working with midpoints, would B be the midpoint? Is it in the middle usually? Yeah. Okay, so for a counterexample, what we need is we need that B to not be in the exact middle between those points. It has to be the midpoint. Okay, so I'm going to do AB. Let's give it a measure. Someone come up with a number for me. 18 feet, meters, inches, miles. Yikes. 18 miles. It's a long ways. How can I draw a segment from B that is also 18 miles, where B is not directly in the middle between A and C? Yeah, I could go up. Put C up here. I would have gone down probably if I would have thought about that because I kind of ran out of space. That's 18 miles. Are those two segments congruent? Are they the same?
They're both 18.
They're both 18. They don't look the same because I did a really bad picture, but I wrote 18 next to it, so they're the same. Is B the midpoint? Remember for midpoint means it has to be on the line right in between them. So C would have had been over here. So here we have AB is congruent to BC, but it's not the midpoint. So we can show that this rule is not always the case. This isn't a law. It doesn't work every time. So we have that counterexample. All right, for your practice work today, it's going to look a little different. Those of you that have had maybe, if you were in algebra last year, algebra 1.2, this might look similar to you. If you were here for algebra 1.2 at Apollo. If you were not here at Apollo for algebra 2, or maybe you were DLA, or maybe you just never did these assignments, we're going to go through the assignment. So everyone go ahead and take out Schoology, because I want you guys to all look at this. Go to week 3 and find your 2-1 assignment. Everyone do this, even if you're not done with the notes, take that out. I'll get you the notes in a moment. I just want everyone to do this.